Let's go.
I will discuss all those things. Firstly, we know what is SN1. If you want to know the SN1 reaction, there are three terms SN1. Firstly, S for substitution, N for nucleophilic, and 1 for unimolecular. Okay, now we know what is the SN1. Suppose it's a substrate, and here we see that is R and X. X is a living group, and some solvent is given nucleophilic. That's the general reaction of SN1. Okay, if you want to know the mechanism, I am discussing here. That's the mechanism. That's the first step where the substrate is Rx and X is the living group here. I will discuss what is the living group later. That's the first step. That's the slow step which we call RDS. RDS means rate determining step. That's the RDS. The reaction rate is depend upon this step. That's the first transition state, and here is the carbocation and the living group. And that's the second step. That's the carbocation. The nucleophilus is reacting here, and it's the first step. That's the second transition state, and that's the second transition state, and that's the product. If you want to know a real example of this mechanism, here we can see that's the 3 degree type of carbocation that will be, and that's the VR. It will be living group when nucleophile giving. There's the product and the living group here. Okay, if you want to know the mechanism, that's the mechanism. Firstly, we can say here that the first step, that's the 8 electron species, that's the full field. Okay, that's the stable. Then why what the reaction occur? You can see here that that's the slow step, that's the first transition step, and it is a carbocation. Okay, a carbocation 6 electron species and the Br minus living group, and it is a second step. A carbocation react with a nucleophile. That's the first step, and the transition step here, second transition step. That's the product. That's also after complete. But if you want to know why the reaction go here to here, that's also stable and stable. We have to know the energy profile diagram. I will show you. It's the energy profile diagram. This side goes energy and that side reaction progress. That's the first is reaction here. A reaction, there's a what? That's the substrate, and is a weak sigma bond. Here is a weak sigma bond. It will be broken. Okay, it will break, and in this step, this is the first transition state, and here the carbocation 3 degree carbocation intermediate. It is a second transition state. Reaction will go here to here, and that's the product. We can see it generally that there's a reactant energy level and the product energy level is lower than it, so the reaction occurs. That's intermediate. Okay, here we can see the energy profile diagram of it. I will show you what is a living group. Okay, first we can see reaction rate depend upon substrate concentration order. That's the first order reaction, and molecularity 1. It's the summary, some kind of. And if we want to know the stoichiochemistry of product, there's a stoichiochemistry of product. Here we can see the reaction. We know that carbocation is a TP means trigonal bipyramidal. That nucleophile can go this side or this side. That's the 50-50 chance. Okay, although that's the 50-50 chance, it will be a 50-50. Okay, what in which side the living group? Okay, living group position this side, then this side some less amount, we can say it, some less amount product. Okay, I will discuss it later, but that's the process. That's the whole process, you know it. That's the energy profile diagram. These are some living group, I minus, Vr minus, Cr minus, F minus, and that all you can see it. Okay, comment what will be the next topic.